Section 6.3 is entitled Elimination using Addition and Subtraction. And this is the third way that we're going to look at to solve a system of equations. Remember, in the first section in this chapter, we solved a system of equations by graphing. In the previous section, we used substitution. And in this section, we're going to use something called elimination. And it's a method in which you add or subtract the two equations in order to eliminate one of the variables. So the two equations must have the same or opposite coefficients for one of the variables. We'll take a look at several examples here. Okay, my first example is the system negative 4x plus 3y equals negative 3 and 4x minus 5y equals 5. Now if you look at these two equations, you'll notice that the coefficients of x are opposites of each other. The coefficient of x in the first equation is negative 4, and the coefficient of x in the second equation is a positive 4. So what this means is that if I add these two equations, those 4 x's are going to cancel each other out. Let's go ahead and add this to our notes here. Since the coefficients of x, that is negative 4 and 4, are opposites of each other, and what that means is that one is positive and one is negative. If I add the two equations, then the x's will be eliminated. And that's a really good thing, because then I can solve for y. Okay, so I'm going to add these two equations because my coefficients of x are opposites of each other. So I put a little plus in front. I like to put it in parentheses. And now add the two equations. Well, negative 4x plus 4x is 0. They cancel each other out. Now let's add 3y minus 5y gives me a negative 2y. And negative 3 plus 5 gives me a positive 2. This is great. I've got one equation that has only one variable in it. So if I divide both sides by negative 2, I know that y is equal to negative 1. Now I need to find my x. So I'm going to substitute that back into either of the equations. I think maybe I'll just go with the first one. So I'm going to take this and plug it back into the original first equation. And now I can solve for x. So that's going to give me negative 4x plus 3 times negative 1, because that's what y is, equals negative 3. And solving that for x, 4x minus 3 equals negative 3. Adding 3 to both sides, I get 4x equals 0, which means that x is equal to 0. So my final answer is the ordered pair 0, negative 1. So notice what we did there was I noticed that the coefficients of x were opposites of each other, so I added the two equations. Let's take a look at an example where you're going to subtract. Here I have the system of equations 6x minus 3y equals 27 and 2x minus 3y equals 11. So I'm noticing that my coefficients of y are the same to each other. So negative 3 is the coefficient of y in the first equation as it is in the second. If the two numbers are the same, if I subtract them, I'll get a 0 because negative 3 minus negative 3 gives me 0. So since the coefficients of y are the same, since coefficients of y are the same, I'm going to subtract the two equations, and that will eliminate my y. So let's put a minus sign out front, put it in parentheses so you don't think that that's a negative 2x. Okay, and now we're going to subtract 3 times. 6x minus 2x is 4x. Negative 3y minus a negative 3y is 0, so that cancels out. And then 27 minus 11 gives me 16. Now I have the equation 4x equals 16. Divide both sides by 4. So x equals 4, which is really great. Now take that x and I can substitute it into either of the original equations. I think I'll do the second one because I don't know, the numbers are a little smaller. I kind of like the looks of that. But it'll work. It should work in either one, so don't worry about which one you put it into. So 2 times x, which is 4, minus 3y equals 11. So 8 minus 3y equals 11. Solving that for y, subtract 8 on each side. Negative 3y equals 3. And dividing each side by negative 3 gives me y equals negative 1. So my final answer is the ordered pair 4, negative 1. In this example, we saw that if the coefficients of one of the variables were the same, we could subtract to eliminate that variable. And my last example here is a word problem. It says find two numbers whose sum is 41 and whose difference is 9. And as always with a word problem, we need to define our variables. We need to write let statements. Okay, so I'm going to say let x equal the first number and let y equal the second number. Now it says I need to find two numbers whose sum is 21. Remember, sum means add, and whose difference is 9. Remember, difference means subtract. So what that means is when I add these two numbers, I get 41. That's the equation x plus y equals 41. And when I subtract these two numbers, I get 9. That's the equation x minus y equals 9. And there's my system of equations. Now, I can solve this. I could solve this using substitution, but let's go ahead and use elimination since I think it's going to be easier in this case. Notice that the coefficients of x are 1. They're each 1. They're the same, so I could subtract these two equations. Notice the coefficients of y are 1 and negative 1. They're opposites of each other. And to be honest, I prefer to add if I can because I tend to make fewer mistakes than when I subtract. So I'm going to add these two equations. And when I do that, that'll eliminate my y's. So x plus x gives me 2x. My y's are eliminated. 41 plus 9 is 50. Dividing both sides by 2. X is equal to 25. And then substituting that back into either of the original equations. I think I'll go with the first one. That gives me 25 plus y equals 41, and subtracting 25 from each side, I get that y equals 16. Okay, so your two numbers are 25 and 16. And in this case, wasn't really given to you as a system of linear equations. You don't have to write it as an ordered pair. If you do, that's okay, but we're just looking for the two numbers. So in this section, we took a look at a third way to solve a system of equations, and that is by elimination using addition and subtraction. If the coefficients of one of the variables are opposites of each other, you can add the two equations to eliminate that variable. If the coefficients of one of the variables are the same, you can subtract those two equations to eliminate the variable and then solve the rest of the system using substitution.